Yeah, you can plug in your laptop.
Just for those of you on the stream or on Zoom, we'll start hopefully in a minute or so. Try and get everyone into the room. We had a late lunch, later than expected, so it's knock-on delay, unfortunately.
Okay. By the way, give me signals when I get close to the end. So, welcome everyone. I would like to talk to you about the shell environment. I'm Alex, also known as Lexmin in GitHub, one of the maintainers of EasyBuild, and I've been quite involved in 5.0. So what is this about? Why do we care about the shell environment? I mean, I'm sure that you've been in this situation when you just try to run some software that you probably installed with EasyBuild, and then you get all these kinds of errors like some header file was not found, some library is not linked, and then you go mad thinking, why is my software in the system not found? Well, all this turns out that can be controlled through shell environment variables, like cpath, ld library path. Path is probably the most well-known. And all of these are shared paths. So shared paths, search paths are a kind of environment variable that contains a list of paths where things, basically files, can potentially be found in them. So for instance, when your compiler looks for header files, cpath is the search path for header files. So it contains folders that potentially can contain the header files that are needed. Same goes for ld library path for libraries, and also path. Path is just a list of folders that contains executables. And with regards to EasyBuild, there are two scenarios. We have the runtime environment and we have the build time environment. Your users probably only know about the runtime environment. And that's the environment that you have when you actually not use EasyBuild, you use the modules generated by EasyBuild. And for all of you that work with EasyBuild, probably you're more used to the build environment generated by EasyBuild at build time. And that's a more complex matter than what happens at runtime. At runtime, basically, things are controlled by modules because there's nothing else. So it's actually quite clear to know what's happening. You can just even run the EMV command and check what's on your shell. At build time, EasyBuild does things. And those things are more hidden, more difficult to check. So we'll get into those. As I said, most of the environment is controlled through modules. EasyBuild just generates those modules, and then when you load a module, that module does things to your environment, the environment on the active shell that you are in. With regards to search paths, what you are mostly interested in are setting new environment variables, new search paths, or also appending extra paths to the ones that are already defined in the environment. So how does EasyBuild control that? So because whatever is done by the module actually is injected into the module by EasyBuild. So that's something that is defined by the EasyBuild installation. So EasyBuild has in framework a module step, which probably you already know. So it's the module step is what happens after the installation. So there's the configuration step, build step, installation step. And at the very end, EasyBuild will generate the module. And that's the module step. And in that step, as you can see, many things happen. So EasyBuild will inject the description of the module, it will inject the group checks of the module, the dependencies, all that stuff. And then there's this make module rec. Rec is for requirements. And those are actually it's the method that will actually inject the prepend path, append path methods into the module to actually modify the environment. In EasyBuild 4.9, though, the situation was a bit messy, and it was clear that this thing grew organically, and there was a lot of code in different places doing similar things. So we have, for instance, the make module rec method to actually use this, the make module rec guess method, which if you ever code a custom EasyBlock, you might be familiar with it, which is another method, a secondary method that basically defines a dictionary. And that dictionary has keys per environment variable, and each key will have the list of paths. It's very simple, but it's a bit weird that this is a method, because a dictionary defined in that way is kind of a static structure. So why do we have a method for that? So that's the first red herring. The second is that the make module rec actually has a lot of logic about different environment variables. Like for instance, if there's CMake library path, it had some logic about that. If there's another environment variable that needs a special treatment, it has some logic about that. So it gets messy very quickly. And on top of that, that method never did glob pattern expansion. And actually, by definition, or how things have been designed from the very beginning in EasyBuild, you can define environment variables with glob patterns. So you don't need to actually specify the exact path to your let's say the site package directory of your Python software. You can just actually put a star in there. So you don't even need to mention the Python short version necessarily. And EasyBuild should be able to handle that. But that was not done in EasyBuild 4. And also mod extra paths, which is the EasyConfig parameter that serves to actually modify search paths in EasyConfig. So that's the interface at the EasyConfig level for this kind of modification, was actually not handled by the make module rec. It had its own standalone code, injecting directly code into the module file, which is also weird. It's like, why are we duplicating this function that it's common in both cases? So we have improved a lot how this works in EasyBuild 5, and we still have the make module rec, but now make module rec has been basically redone. And what it will do is first update the module environment with whatever is defined in the mod extra paths EasyConfig parameter of the EasyConfig that it's being installed at the moment. And then it will parse this module load environment variable that I will explain what it is in a moment. It will do path expansion so that glob patterns are respected and not just injected into the module file, which will never work. And then it will generate the module file. And what is now much better improved is this module load environment thing. This is the new thing that it's gathers all the structure of the shell environment. And it is a kind of a data class. So it's kind of a static in nature by definition. So there's little logic in it. It's the module load environment is basically has a list of attributes where each attribute is one single environment variable. And it has some extra methods to actually manipulate that environment, like extra methods to add more shell environments, update shell environments, remove shell environments, all that kind of usual manipulation that you need to do in your shell environment. And each one of these shell environments that is defined in the module load environment is actually its own different data class, which is also, well, it's a different class, which is a kind of data class, where you get the definition of one single shell environment. But the nice thing about this data class, which is also kind of static in nature, is that you not only have the paths that you want in that search path, you also have some attributes, some extra attributes that allow you to customize how this search path will be transformed into the module. So for instance, you can change the delimiter used between the paths, which is usually a colon. But in some cases, and we've found those in our experience, use different separators. So you need to change that sometimes. Also, you can define if that search path needs to be appended or prepended into the search, into the environment variable. Under those nice little things that you can define at the variable level. However, there's no logic about exporting any of that into the module file, because the idea here is that that contains just the definition of the environment and nothing else. So then the situation now in 5 is much simpler. We have framework that will initialize your EasyBlock. So for any EasyConfig that you install, EasyBuild will initialize the corresponding EasyBlock. And at the very beginning, we'll get the module load environment. And that module load environment will have the default environment definition. So by default, we have cpaths, we have, well, cpath no, but by default we define path, LD library path, cpath as well, and some others like manpath, something about cmake also is defined. So that's the default definition. Then at the module step, make module rec will kick in, and we'll actually read all of that, inject the mod extra paths EasyConfig parameter, expand the paths, and then generate the module file. So that's the basically 3-step procedure in all installations. And now, if you want to change that at the EasyBlock level, because you have a custom EasyBlock that needs some special treatment of some search path or something like that, you can access the module load environment now in all the steps, because it's defined from the very beginning. So you have access in whatever. You can be in the configure step, you can modify the module load environment, no problem. However, you might be a bit careful there, because you need to try to be sure that everything works when you just run EasyBuild with module only option, which means that no installation is happening, just so there's no configure step, no build step, nothing else, just extraction and module step. But that's a detail. And then if you, for instance, need to define some search paths that depend on the actual installation files that have been put in the installation directory, so this is something that happens at the end of the installation, then you can just use the module step function and then just in there do your modifications to the module load environment. And some examples are here, for instance, what you can do in your EasyBlock. So you can just access attributes in the module load environment by name very easily, and then just modify them in any way you want. You can just assign lists or strings. Those will be converted into the module environment variable class. And you can also use the methods, like for instance, we have the remove method if you want to remove one of the variables. All of that is accessible very easily in code. And then at the EasyConfig level, now there's mod extra path becomes the single point or the single interface accessible to actually modify the shell environment. So before we had mod extra path and also mod extra paths append, and then we have some other EasyConfig parameters with very weird names like apps something something to actually allow for absolute paths. It was complex. Now there's only mod extra paths, nothing else. And mod extra paths now accepts a dictionary with all the different options which correspond to the actual attributes that I taught before that had the module environment variable. So like for instance, you can change the delimiter from here and put whatever you need. You can also decide if you want to prepend or append, that's fine. Also, absolute paths are now accepted by default. If you put an absolute path, that's fine. EasyBuild will check for the existence of those paths, but if you are not forbid to use them. And then we have the build environment. And the build environment is different. Nothing of this really matters there, because actually, EasyBuild will, of course, load the modules when it's building its software, so all the dependencies will get loaded. The module will be loaded in the normal manner, so all the changes to the environment will happen. But then EasyBuild will just inject in the environment some extra parameters, some extra variables, let's say, that ensure that the build is sane and that will happen as expected. And this is actually a good thing, because just entirely relying on the modules, it's a flaky design, because you never know what comes with the modules. There might not be any changes to the environment at all. You can make a module for GCC and not change path at all if you want. So this is a more reliable approach, but then it means that some stuff happening at the build time is hidden or less visible for us as users. And this all happens at the toolchain level. So toolchains are not just an EasyConfig that has some dependencies and defines what is used for a collection of software. There's a lot of logic in toolchains in EasyBuild. And one of the things that it does is actually modify compiler and linker options at build time. So once, as you can see, the first thing that it does, this prepare step in the toolchain, is to actually load modules. While it checks dependencies, then it loads modules, so the environment will be updated. But then, EasyBuild will generate its own linker and compiler flags, which means that EasyBuild will go through the dependencies, check all the include directories, check all the lib64 directories, and then generate a list out of that, and then inject that with different methods. And in 4.9, there was just a single method, and it was through flag. So it was CPP flags, which is the preprocessor flags in the GCC compiler. And that's affect the header file. So that translates into the -I options in GCC, which has the top precedence on how headers are injected into the compilation. So anything that goes there goes first, and then the compiler will check cpath, and then afterwards there's C include paths and other stuff. And for the linker, it happened through LD flag. So EasyBuild will gather all the lib folders, translate that into the LD flags, which get injected into the compiler, well, into the linker command with the capital L option, and that has absolute precedence over anything else defined in the environment. It turns out that this is very reliable as a method to actually ensure that things are found at build time, but also it's a bit hardcore because it's very difficult to modify that. Whatever is injected by EasyBuild at the very end cannot be, it's very difficult to be modified through modules or other options in your environment. So in 5, we added these two options that allow to actually use other methods that have less precedence than just passing flags into the compiler. And one is search paths is CPP headers, which allows to replace the CPP flags option with cpath or the C include paths. Each one has less and less precedence, and it's your choice to actually decide which one is the best for the software being installed. And the same for the linker. Instead of using LD flags, now this option allows you to use library path, which is an environment variable that has less precedence than the capital L options in the linker. And by default, EasyBuild will continue to use the flags. You can choose to change that as an opt-in feature, because the reasoning is that software needing to use less precedence options, well, options with less precedence, should be the exception, not the rule, or it's very environment dependent as well. So that's something that you will find yourself in this situation if you need to, but in general, should not be needed. So as a conclusion, EasyBuild 5 is great. We have a lot more extra options and features and a better design to install software. And with that, I'm done.
I have a question. So with the way the module thing is done now, is it much less likely that someone can break the reproducibility of module only? So like I did it, I think I did it myself recently. Like yeah. if I try and inject a path in a build step, for example,
there's nothing in place that will forbid you to do that, or there's no warning that will tell you this might be a bad idea.
Sometimes it can be tricky, right? Because you don't know if you should or not until
yeah, probably the solution we can need, well, yeah, it's.
I guess
I'm thinking to have a warning or something like that printed if you use module load environment in a build configure step could be something useful.
Because really what you want is to force them to do this thing in the module step, right? The actual, constructor if you can, but if you can't, you need.
So right now, after updating all the easy blocks, the end result is that we use this mostly like 80% is in the init of the easy block. In the init, because anything that is static that you don't need to check for the installation of files, you can just put it in the init. You know the results, so you just put it there. Sometimes in the prepare step, that's also fine, because then if you need to know something about dependencies, those get loaded at the prepare step. And those get loaded at the prepare step, and then you can check for dependencies. That's the second place. And then the third is module step. That's where you need to check the actual installation that you just done.
Yeah, I remember where it was now. It was with this thing I'm trying to do with exporting the RPath wrappers. So they're part of this build env thing. You don't know if you've done that. Like you don't know if you're going to do that until you start doing the build step, right? So how am I configured? Yeah, and you don't know what you're going to have necessarily. You don't know the paths because the RPath wrappers are in a subdirectory which is connected to the compiler name. So you'd have to do a lot of, maybe you could do that in initialization steps, maybe.
They're set up in the preprint step.
Yeah. Not sure. Anyway, I know I probably broke it.
No, but having such a warning is not a bad idea, actually. Yeah, just to discourage using that in build, configure, install steps.
Question from online. Is the structure of the code described somewhere at a more introductory level?
Is that? Can you prove it?
Yes, Alex's talk from last year. You did a talk on the framework structure and how everything fits together.
We have documentation.
And it's in the documentation as well.
We have documentation. Wait.
Yeah. It's a good question. You can find it in the documentation. Or see Alex's recorded talk from, I think, last year or 2 years ago. It's maybe 2 years ago. Yeah. But the general structure is
2 years ago, yeah. Now, I don't have.
Yeah, okay.
It doesn't matter.
Yeah, but it's in the documentation.
It's in the documentation, yeah. We can give you the link later in chat.
And they say the documentation is not clear. We have to reverse engineer how the easy block
No.
works. Okay, then we can improve on that. Yeah, so that's Roberto's comment. Yeah. Yeah, so feedback about the documentation stuff is not clear. That's good feedback as well, huh?
That's the documentation.
Yeah. Any volunteers to improve? That's good.
Yeah, because, well, actually this is 2 years old, so.
Yeah, this probably needs a revision. I mean, the general structure hasn't changed, but
not much.
a little bit, some details will no longer be correct or at least up to date. Yeah. Okay.
There at the back.
Yeah, hi, very nice talk, thank you. Naive question, is there always one module per package in that sense? I'm asking because I once tried using modules for a software stack in high energy physics, which tend to be ridiculously big. So it's on the order of 500 packages. And at that scale, we saw that just loading the modules for all of the packages actually became really slow.
Yeah,
so have you ever given a talk to that issue if you have like really lots of packages?
I confirm that this is an issue and it's becoming more and more of an issue. For instance, that's what happens with the bio packages that have a lot of dependencies. And we see that sometimes some modules take a lot of time just to load because you have, for instance, in our experience, 180 modules that need to be loaded. So it's 180 stat commands into the file system. So that can be really slow. Solution at the EasyBuild level, there's none. You could create, if the nature of the packages that you are installing allows it, and a bundle of extensions, for instance. So if everything is Python, you can create a bundle of Python extensions, and that will generate only a single module file. Or if everything is R packages, for instance, that's also doable. But you can also create a module that it's a bundle of components, and then every component can be a different thing, but that generates just a module file, but it's a bit more work to do because then you need to code all the components one by one. But I can show you examples later if you want to know.
I mean, outside of the EasyBuild context, you could create something that condenses modules together, right? You could say this environment, pack it all together into like the commands you have, right? Path, library path,
exactly.
Condense them all together into a single module. So on the system, there's still whatever 500 packages, but you can say, take this entire environment and condense it into a single module file for me.
Yeah. Actually, that would be possible too. I've been toying in my head with the idea of having everything in a single toolchain generation, like 2023A or 2024A, installed in the same root installation directory. Because since we only allow one module, one version per software, per toolchain generation already, there's no collision in the namespace, so there's no binaries that have the same name. So you can technically install all the libraries and all the binaries in the same folder, and only have one path.
And if you did a helper tool, you can check for name collisions, right? You can check, because it still could be the case that something is installing LLVM, right? So you could say, don't don't allow name collisions. Don't allow me to shadow libraries or anything like that.
Yeah.
You could do tooling around it to make it better.
But it's just an idea in my head, so.
It's not a generic solution either, but I think GUIX or GUIX or the non-GUIX version, I forget, Next has a patch to glibc to have per directory LD caches. So that would maybe, like for C applications, it would speed up the loading, at least of the shared libraries, the path resolution.
Okay.
That, but nah, that's a very specific solution. But for easy, you could have that patch in glibc for the Gentoo prefix stuff.
Okay, that could be. Yeah, I was not aware of that.
Yeah, I mean, for easy, there's an interesting one because you can forget about searching at all, right? Just put the full path in there to the library and just, that's it, no searching anymore.
Yeah, that's actually, our path is the default in EasyBuild, and in easy, I mean.
But with RPath, you still have some level of searching, right? You're still going to have, because it's just a directory. The RPath is just a directory.
Well, yeah, you still
but there's another way of doing it. We don't
the
support that in EasyBuild yet, but there's another way of doing it where you can just give the entire path to the library,
file,
and there's no searching. But you don't necessarily always want that either.
Hey.
That whole idea of condensing various modules into a single one, I think that's a good one if we do that for the toolchains, for example. So if you load FOSS 2024A, you only load one module and not 10 because you've got all of the dependencies. How about that?
Yeah, that's exactly my idea. Yes, to have that that kind of module where you can, so users would just load FOSS 2024A and automatically have all software available in FOSS 2024A.
Yeah, but important point is a single module.
Yeah, with a single module. Yeah, exactly.
That would be something for EasyBuild 6. Kenneth was asking for ideas.
I mean, that's even a side thing, right? You could do the normal thing by default, and then you can create extra tooling to do whatever you want, right, with these module files. Like, they're just a piece of data, right?
Well, since that could be an enhancement, it can be introduced at any version. That's not...
Since this idea is gaining traction now, let me pose a problem there. We do have a one dependency per toolchain policy, right? But we can support multiple GROMAX versions in a single toolchain. So your idea of like, I will just load, everything that's built with FOSS 2024 in one environment, I don't think that will ever work. But your idea where you're saying, okay, at least the toolchain itself is unique, right? Like there's only one FOSS 2024. That you could package in a single module for sure.
Yeah, like you mean having all the core level packages like binutils, zlib, all that stuff in the same module, in the same installation there. Yeah, but just the core level of everything in the ecosystem. Yeah.
Anyway, we should probably move on. It's time.
Yes. Thank you.